Hello dear, how are you all? In this problem, we will find the sum of 1 by 3 plus 1 by 15 plus 1 by 35 so on 1 by 4 n square minus 1 is equal to n over 2 n plus 1. We have to prove that this statement is true for all positive value of n by induction. Prove by mathematical induction that statement is true for all positive values of n. If we want to prove by mathematical induction, we first prove it is true for n is equal to 1. We check for n is equal to 1. When n is equal to 1, we replace n is equal to 1 in statement. We will get 1 by 4 1 square minus 1 is equal to 1 by 2 times of 1 plus 1 4 minus 1 1 by 3 is equal to 1 by 3. Both sides are equal. We can say that C1 is satisfied. Condition 1 is satisfied, means it is true for n is equal to 1. It is true for n is equal to 1. It is true for n is equal to 1. Now, in second step, we assume that it is true for n is equal to k. We now assume that it is true for n is equal to k. So we can replace n by k. We will get 1 by 3 plus 1 by 15 plus 1 by 35 so on 1 by 4k square minus 1 is equal to k by 2k plus 1 and we call it statement B. In second step, we assume that it is true. We assume that it is true for n is equal to k. In last step, we have to prove that it is true for n is equal to k plus 1 on the basis of this assumption that it is true for n is equal to k. So, to prove that it is true for n is equal to k plus 1, we add an expression. We add an expression in statement B. What expression we should do add? We should add an expression which is obtained by replacing n by k plus 1 in the left side of given statement. The left side of this statement is 4 n square minus 1. The left side of given statement is this 1 over 4 n square minus 1. We replace n by k plus 1. We replace n by k plus 1. The expression in this way we obtained. We add that expression in both sides of B. We replace n by k plus 1 4 times of k plus 1 4 square minus 1. This expression we should add on both sides of B. To prove that it is true for n is equal to k plus 1, we should add 1 by 4 k plus 1 whole square minus 1 on both sides of B. So, we should add 1 by 4 k plus 1 whole square minus 1. To prove that it is true for n is equal to k plus 1, we add 1 by 4 times of k plus 1 whole square minus 1 in both sides of B. Both sides of B. We will get 1 by 3, 1 by 15, 1 by 35, so on, 1 by 4 k square minus 1 plus 1 by 4 k plus 1 whole square minus 1, and in right side of B we should add k by 2k plus 1 plus 1 by 4 k plus 1 whole square minus 1. We will solve. After simplification, we just simplify this term. 1 by 4 k plus 1 whole square minus 1 as 1 by 2 times of k plus 1 whole square minus 1. 1 by 2 times of k plus 1 whole square minus 1. We can write it 2 times of k plus 1 plus 1 and 2k plus 1 minus 1. 2k 2 times of k plus 1 minus 1. You know, if there is a scale, if there is a negative sign between two scales, first we add two terms and then we multiply and then we subtract these two terms. Like that, if a square minus b square, we can write a plus b, a minus b. So we write it 4 times k plus 1 whole square as 2k plus 1 whole square. We write it 2 k plus 1 whole square and this one as 1 square. There are two square having negative sign between them. We can write 2 times k plus 1 plus 1 and 2 times k plus 1 minus 1. After simplification, we will get k by 2k plus 1 plus 1 by 2k 4 times of k plus 1. We write 2 times of k plus 1 whole square minus 1, and we now write k divided by 2k plus 1 plus 1 by 2 times of k plus 1 plus 1 and 2 times of k plus 1 minus 1. We now write here on right side k divided by 2k plus 1 plus 1 by 2k plus 2 plus 1 makes 2k plus 3, 2k plus 2 minus 1, 2k plus 1. By taking 2k plus 1, 2k plus 3 as an LCM, we will get k times of 2k plus 3 plus 1. After multiplying, we will get 2k square plus 3k plus 1 divided by 2k plus 1, 2k plus 3. After factorizing, in numerator we write 2k plus 1 k plus 1. We factorize 2k square plus 3k plus 1 as 2k plus 1 k plus 1. 2k plus 1 and 2k plus 3. Cancel these two terms. We will get k plus 1. We will get k plus 1 divided by 2k plus 3, and we write k plus 1 divided by 2 times of k plus 2 plus 1. Finally, we will get k plus 1. We write 2k plus 1 plus 1, and this is the expression. This is the expression as required as same. If we now replace n by k plus 1, this will be same as this statement. This proves that it is true for n is equal to k plus 1. Hence, by induction we can say that it is true for all positive value of n. Hence, by induction we have proved that it is true for all positive value of n, because when we replace n by k plus 1, we will get k plus 1, and in denominator n replaced by k plus 1, we will get 2 times of k plus 1 plus 1. Hence, by induction it is proved that given statement is true for n is equal to k plus 1. Thank you.